Hello everyone, myself Pranjal Sharma. This is a new series of video for those students who is preparing for different competitive exams like NET, SLATE, GATE, etc. In this series of videos, I will solve problems of previous year question papers of those exams in segment wise. In today's video, I will solve the mathematical physics portion of GATE 2020 paper. So, for the first question in GATE 2020, mathematical physics. The first question is in your screen, so pause this video and read it. In this question, so question number 1, here the question asks to find solutions for a differential equation equal to k square x. So where k is real, okay? So we have to find the solution of ux. So we have to find ux. So this is a second order differential equation, and so we may write it as so it is a second order differential equation, it's a homogeneous equation, okay? So right hand side is 0. Now if we take solution, let ux is equal to c1 or c e to the power alpha x, then du dx equal to c alpha e to the power alpha x d square by, so double differentiation gives c alpha square e to the power alpha x. So we put the values in this equation, so it will give c alpha square e to the power alpha x minus of k square c e to the power alpha x is equal to 0. And from this equation we can write c alpha square minus of k square e to the power alpha x is equal to 0. So here the auxiliary equation, so the auxiliary equation here alpha square minus of k square is equal to 0. So alpha square or alpha is equal to plus minus of k. So it has two different roots. So the solution of this equation can be written as, therefore ux equal to u1x is equal to c1 e to the power kx, or u2x is equal to c2 e to the power minus of kx, or the solution can be written as the linear combination of both of them e to the power kx plus c2 e to the power minus of kx. In your options you will find this result. So in your options you will find this term in option A, so your answer is A. Okay, so okay, the next question. Now question number 2, so which is in your screen, so pause it and read the question. Okay, here it gives a matrix, a 3 into 3 inversible matrix with eigenvalues 1 2 3, with eigenvalues lambda I, where I equal to 1 2 3. Obviously it is a 3 into 3 matrix, so it has 3 eigenvalues, and which are corresponding for the corresponding eigenvectors of ei. So it is ei cat, so it is a cat vector which so here Okay, so we know for eigenvalue equation, if eigenvalue equation is simply m ei is equal to lambda ei. This is the eigenvalue equation. Okay, and in your option, this option is not available. And another option is, if we take the inverse of m, then for m inverse the eigenvalue will be reciprocal to original eigenvalue. So this equation will be this. These are the properties of eigenvalue equation. So in your question, the option 2, which gives this equation, so question number 2, this is the option. Option B is the correct answer for question number 2. Okay. Now question number 22. So question number 22, here you have to find the integration of, you have to find the value of this integration, plus 3 by z square dz. Actually this question is come from residue theorem. Here z equal to 1 for the contour. That means if we draw x and y, so the region is where, so these points are 1 1 1 1, so it is a unit circle. Okay, it is a unit circle. And for here, if we take here, fz is, this is the portion of fz, so fz is equal to z minus of 2 by z plus 3 by z square. So in this function, so z equal to 0 is the pole, and it is second order pole, since here z square term is associated, so it is a second order pole. Pole is z square, that is second order. Okay, so you have to apply the residual theorem. That means, so from the definition of residue, so definition of residue of fz is equal to nothing but coefficient of 1 by z in fz. So it is coefficient of 1 by z in fz. In this case, coefficient of 1 by z is minus 2, right? So from residue theorem, so we know that from residue theorem gives that integration of, so it is fz dz equal to twice pi I sum of residue. So if we write this twice pi in here, so twice pi equal to integration of, see fz is equal to, here is z minus of 2 by z plus 3 by z square dz. So here only sum of residue, here only one residue is present, so it is residue value is minus 2. So the answer is minus 2. Okay. Okay. Now the next question is question number 26. So in 26 we need to find the product of the eigenvalues of this matrix 0 0 1 0 1 0 1 0 0. So this is okay. So we need to find the product lambda 1 dot lambda 2 dot lambda 3 equal to 0. So let, in this case, let lambda be the eigenvalue. So circular equation, in this case, can be written as what? 0 minus of lambda, 0 1, 0 1 minus of lambda, 0 1 0 minus of lambda is equal to 0. This is the circular equation. Okay, so you have to calculate the determinant. So 0 minus of lambda, sorry, this is lambda into 1 minus of lambda into minus of lambda equal to minus, so it is 0. So minus of the second term is 0 because this is 0. The third term is simply plus 1. So in this case, so 0 into 0, 0 minus of 1 into 1 minus of lambda, so 1 minus of lambda, so is equal to 0. Now, so minus lambda into minus lambda, this is lambda square, 1 minus of lambda, and this is plus 1 into minus, so it is minus of 1 minus of lambda is equal to 0. So 1 minus of, we write as this. So here eigenvalues are, so lambda equal to, eigenvalues are here, lambda equal to 1 and lambda is equal to plus minus of 1. That means there are 3 eigenvalues here. Lambda 1 is equal to 1, lambda 2 is equal to 1, lambda 3 is equal to minus 1. So their product lambda 1 dot lambda 2 dot lambda 3 is equal to 1 into minus 1, that is minus 1. So in this case the option is A. Okay. Now question number 27. So it is on your screen. So pause the video and read it. Here it gives 3 cat vector e1, e2, e3. Okay, and we get a okay. Here we get 3 cat vector. So this is e1 equal to 1 0 0, e2 equal to 1 1 0, and e3 equal to 1 1 and 1. So these all are 3 into 1 column vector. So from your options, the very first thing you have to find is that these are 3 into 1 vectors, 3 into 1 column vectors. So these are obviously set of RQ space at first. Why? RQ spaces means it is 3-dimensional real vector space. Okay, so here the option C is, in option C it says that S is basis for R cube, so that option is obviously correct. But let's check if the others options are correct or not. At first, check if e1, e2, e3 are linearly dependent or independent. So for this we have to find S. S is simply, it says that it is e1, e2, e3. So it is simply 1 0 0, 1 1 0 and 1 1 1. If determinant of S is equal to 0, then it gives linearly dependent set. A linearly dependent independent means you can express other factors in terms of E1 in terms of E2 or E3, or E2 in terms of E1 or E3 not. If it possible, then it is linearly dependent. If it is not possible, then they are linearly independent. So the good way to find whether they are linearly dependent or not, we have to find the determinant of S matrix. So here the determinant of S is, so for 1 into, so 1 into 1, so 0, so minus of 1 for 0 into 0, plus 1 for 0 minus of 0, so its value is, okay, so its value is 1, so it is not equal to 0. So delta S is, sorry, so the determinant of S is not equal to 0, so it is linearly independent. It is linearly independent, so option B is not correct. Okay, now S is an orthonormal set. So orthonormal set, it means they have a unique terms and they are perpendicular to each other. So let's check whether they are independent norm, they have E1, E2, E3 have independent norms or not. So for checking E1, checking its norms, so let's check inner product. So in this case, so E1, so this is E1 is equal to 1, 0, 0, so its bra vector can be written as 1, 0, 0. So E1 equal to 1, 0, 0, 1, 0, 0. So in this case, so it is 1 plus 0 plus 0, so it is 1. So the inner product of E1 is 1, so obviously its norm will be 1. So let's check for E2, inner product of E2. In that case, so 1, 1, 0, 1, 1, 0. So here 1 into 1 plus 1 into 1 plus 0, it is 2. So its norm is 2. So obviously if their norms are not 1, so the option 1 is incorrect. Okay, and obviously you can find they are perpendicular or not by simply taking E1 inner product of E1 E2. So in this way you can find, so here E1 is 1, 0, 0 and E2 is 1, 1, 1, 1, 0. So here, so it is 1 into 1 plus 0 into 0 plus 0. So it is, if they are perpendicular, then their value should be, the result of inner product is 0. Here is 1, so they are neither normal to each other. So the first answer, first option is incorrect. Okay, and let's check the fourth option. Here you have to calculate the outer product. So E1, in that case the product like this. So in this case you have to 1 into 1, 1 into 0, 1 into 0, 0 into 1, 0, 0 into 0, 0, 0 is 0, 0 into 1, 0, 0 into 0, 0, 0 into 0, 0. So first one is E1, outer product of E1. Now outer product of E2. So it is again 1, 1, 0, 1, 1, 0. So here 1 into 1, 1 into 1, 0, 1 into 1, 1 into 1 and 1 into 0, 0, 0 into 1, 0, 0 into 1, 0, 0 into 0, 0. So E2 is equal to this, and E3, so in this case 1, 1, 1, 1, 1, 1. So their product is 1 into 1, 1 into 1, 1 into 1. So all these are 1, 1, 1. So if you add all these three, so the results would be what? It simply give, so summation of I equal to 1 to 3 EI EI equal to, which is equal to 1 0 0 0 0 0 0 0 0 plus 1 1 0 1 1 0 0 0 0 plus 1 1 1 1 1 1 1 1 1. So the result is 1 plus 1 plus 1. This is 3. This is 2 0 2 2 0. So 0 1 1. So these are 1 actually. So this is the result. So fourth option is incorrect also. So our only correct option is option C. So question number 32. It asks which of the following matrix does not represent a proper rotation. So in case of proper rotation, so rotational matrix can be expressed as r theta. So in case of proper rotation, r theta, the determinant of r theta is equal to plus 1. So in option A, the given matrix is simply minus of sin theta, minus of cos theta, and minus of sin theta. So its determinant is minus of sin square theta, minus of sin theta into minus sin theta, that is sin square theta. So it is minus, so minus of cos theta into cos theta. So sin square theta, so minus minus plus cos square theta. We know that sin square theta plus cos square theta equal to 1. So option A, it is a proper rotational matrix. So option B give. So again it is cos theta minus of sin theta, cos theta. So in this case, if you want to calculate its determinants, then this cos theta into cos theta, cos square theta. So minus sin theta into minus of sin theta. So it is cos square theta. So minus minus plus, so it's sin square theta. So it is 1. So option B is also a rotational matrix. C, here the matrix is sin theta, cos theta, minus of cos theta, sin theta, right? So here the determinant is sin square theta minus cos theta, minus of cos theta, sin square theta plus cos square theta is equal to 1. So it is also a rotational matrix. So now check the option D, where minus of sin theta, minus of cos theta, sin theta. So here the determinant is minus of sin theta into minus into sin theta. This is minus of sin square theta minus. So this is cos theta minus of cos theta. So it is minus of sin square theta plus cos square theta. So it is minus of sin square theta plus of cos square theta. It is not equal to 1, which is not equal to 1. So in question it asks that which matrix does not represent proper rotation. So the option E. So option D does not represent proper rotation. Your option is here D. So it is a property of rotational matrix. For proper rotation, its determinant value is plus 1. Okay. Okay. Question number 48. So question number 48 on your screen. Pause the video and read it. It says that if x equal to summation of k equal to 1 to infinity ak sin of kx, here the condition is x lies between minus of pi to plus pi. So you have to find what is the value of a2. we have to find the value of a2. So this question comes from mainly Fourier series. In case of Fourier series, we know that fx, the function of x, can be expressed in terms of sine or cosine function. So here fx k equal to 0 to infinity ak sine of kx, k equal to 0 to infinity, k equal to 1, k equal to 1 to infinity ak sine kx. So in this case fx is equal to x. So here you have to find the value of a2. For a2, the coefficient a2 can be here. For a2, k equal to 2 now. That means k equal to 2. So for a2, the limit is minus of pi to plus pi. So the function, we have to write this by 1 by pi, minus of pi to pi. So fx means fx and sine of twice x dx. So here 1 by pi minus of pi to plus pi x sine of twice x dx, or minus of pi. So here this is a integration by parts. So at first this is x, this cos of twice x, minus of cos of twice x by 2 minus, so ddx of x equal to 1, okay, and integration of this equal to again minus of sine twice x by 2 into 2, this is 4, okay, minus pi to plus pi. So we put the limits here, okay, so 1 by pi. If we put the values here, so the first term, so pi into minus of cos of twice pi by 2, okay, again minus of pi and minus of cos of twice pi by 2. The first term is this. The second term is obviously if you put value of pi here, so sine of n pi equal to 0, the second term will be 0. So here the value 1 by pi equal to, so this is minus of pi cos of twice pi 2, so this is again pi, so minus plus, plus, so it is, but this is minus, so this is again minus, so pi cos of twice pi by 2. So here we can take, so this term, okay, so this is 1 by pi, okay, so here minus pi, here also minus is present, so we can take minus pi common. So here cos of twice pi by 2 plus cos of twice pi by 2, okay, so this pi will cancel out, so this is minus of cos of twice pi by 2, cos of twice pi by 2, that is cos of twice pi, so minus of cos of twice pi means minus of 1 square, so it is minus of 1. So the option is here the answer, your answer will be minus of 1. So this is your answer. For this value is a2 is equal to minus of 1. Okay. Now question number 49. So 49, question number 49 is on your screen. So pause it and read the question carefully, what it actually wants. So it gives a function f and x, its value 0 for x is less than 1 by twice n, so minus of twice n. Okay, it gives n for minus 1 by twice n, x 1 by twice n, and 0 for 1 by twice n less than x. Okay, so actually the value is only non-zero at this interval, and all other in all other region the value of the value of x is the value of x is 0. So we need to find the limit of n tends to 0, so n tends to infinity. We need to find limit of n tends to infinity, minus of infinity to plus infinity, f n x sin x dx equal to what? Okay, so in this case let's calculate the integration. Here fn will be present only for this bound, so we can calculate the integration for minus of 1 by twice n to 1 by twice n. Okay, here for fn x is equal to n here, and sin of x dx. So let's calculate this integral. Since n is constant, so we can put out this n from the integral. So 1 by twice n sin of x dx. So n, so integration of sin x dx equal to cos of x minus of cos of x, so 1 by twice n. So n equal to minus of cos of 1 by twice n. Okay, so this is minus, so minus plus cos of minus of 1 by twice n. So we know that cos of minus of theta equal to cos theta. So here n minus of cos of minus of twice n. So this is plus cos of 1 by twice n. So minus of cos of twice n plus of cos of twice n. So it is equal to 0. So n into 0, that is 0. So obviously limit of n tends to 0 is equal to, so this integral is since 0, so integration of fn x sin of x dx minus infinity to plus infinity equal to this is equal to 0. So the term limit of n tends to 0 is equal to 0. So the result will be 0. So this is question number 49. Okay. Anything else? So I think these are the questions came from mathematical physics part. Okay, if I left any questions of mathematical physics, please write it down into the comment section. Okay, I think no questions left. Okay, thanks for watching. Thank you.